This is problem 43 from chapter 15. In problem 43, the 20-gram bullet is traveling at 400 meters per second when it becomes embedded in the 2-kilogram stationary block. We are to determine the distance the block will slide before it stops. The coefficient of kinetic friction between the block and the plane is 0.2. So we're in chapter 14, where we are learning about the impulse momentum conservation law. In this chapter, in addition to the impulse momentum conservation law, we are sometimes using the work energy conservation law as well. So you can feel free to use both of those equations to solve problems in this chapter. We have, before the collision, the 20-gram bullet traveling at 400 meters per second, encountering the 2-kilogram block, which is on a surface that has a coefficient of kinetic friction of 0.2. We want to know how far the block slides after the collision. So I'm going to start off using the impulse momentum relationship, and I'm only going to do this right up until the moment that the bullet collides with the block. Before the collision, it's just the bullet that's moving. So we have the mass of the bullet, which is 0.020 kilograms, times the velocity of the bullet. This is the initial momentum. Now, as long as I'm stopping right when the collision happens, I don't have any kinetic friction because the block hasn't started moving yet. So my impulse momentum relationship, I have initial momentum plus impulse is equal to final momentum. Now, if I do a free body diagram, before the collision, I have the force of gravity acting on the system of the bullet and the block. That is the force of gravity for the bullet and the block together. I have the normal force acting upwards on the block. As long as I stop before the block begins to move, there's no kinetic friction, and so there's no impulse. Right after the collision, I have the total mass, which is 2.02 kilograms times the velocity of the center of mass. Now, we don't know that the bullet is moving with the block. Right after the collision, it might still move farther into the block before it comes to rest relative to the block, but it's actually not going to make a difference. So this is the velocity of the center of mass. I can figure out what this velocity is, and that gives me 3.96 meters per second. Now, after the collision, if I wanted to, I could use impulse momentum. Then we would have to include the force of kinetic friction and the time that it acts for, and this would be the time until the block comes to rest. They asked me how far the block slides. So if I find that time, I'd have to go back to my kinematic relationships in order to find the distance. I think it would be much better, rather than using the impulse momentum relationship, since we're asked about how far the block slides, to use the work energy relationship, because the work is the force, the integral of the net force dotted with dr. Now I can use that equation to figure out how far the block slides. So instead of doing impulse momentum after the collision, we're going to use work energy. And at the moment that the bullet and the block collide, we have kinetic energy, which is going to be given by 1/2 times the total mass times our velocity squared. My initial kinetic energy. In this problem, I don't have to worry about the gravitational potential energy since the block is sliding on a horizontal surface. I don't have any springs attached in this problem, so no elastic potential energy. I do have work done by a non-conservative force. After the block begins to slide, I have the force of kinetic friction acting on the block. So I have the force of kinetic friction. The force of kinetic friction is going in the opposite direction of the motion. So from the dot product for the work, I will have minus the force of kinetic friction. Since the force is constant, it can come outside the integral, and this is times the distance that the block slides. That is equal to the final kinetic energy. When the block stops, the velocity is 0, so final kinetic energy is 0, and we don't have any gravitational potential energy or elastic potential energy to worry about in this problem. Well, from my free body diagram here, I can figure out what the normal force is. The normal force is equal to the force of gravity. The force of gravity is the total mass, 2.02, times 9.81. My force of kinetic friction is the coefficient of kinetic friction times the normal force. So I can put everything in here and use that to find the distance. Why don't I write this as F kf times delta r is equal to 1/2 times the mass times my velocity squared. Then I can divide both sides by the force of kinetic friction. The force of kinetic friction is, the coefficient of kinetic friction is 0.2 times 2.02 times 9.81. And this gives us 3.9971 meters, or 4.0 meters, for the distance that the block slides after the collision.